So we have learned what is light. So we define light as a form of energy or as a form of radiation, right? That requires a medium to travel, and it always travels in a straight line. And that property of light is called as rectilinear propagation, right? Then light can reflect from a medium. It can refract when the medium of the when the medium changes, then it can refract, basically where it would bending. Okay, sometimes it can be absorbed into the surface also, right? And in the beginning I said that it requires a medium. Let me just correct that. Okay, no, it does not require a medium. Okay, so light does not require a medium to travel. That it means that it can travel through a vacuum also. So these are some of the property. Also, we have learned that in the vacuum, the speed of the light is maximum. It is almost 3 lakh kilometer per second. Getting it? So in just 1 second, it is able to travel this much of distance. Getting it? By the way, many times you would have heard of this theory that if we were to achieve a speed more than the light, then we'll be able to travel in time. Huh?
Yes.
Yeah. So you might have heard of this. Getting it? But there are some limitations to this. Getting it? Now, like there is this theory of, like, you must have heard of the theory of relativity, right? Einstein's theory of spatial relativity, that speed of light is the fastest speed in the universe. Okay, and it is said that it is unable to surpass this speed right now. So that is the case. So once you understand this theory of relativity, then you will be able to understand, like, first thing, it is very impossible to achieve speed more than the light. Okay, that is one thing. Plus, when a body will be achieving the speed more than that of light, so for that body, time would be behaving differently. Okay, time would be behaving differently. Okay, in fact, suppose you must have heard of the twin experiment. Have you heard of that twin experiment? Like, if you were to take two twin kids, okay, one of them were to be sent to, one of them were to be made to sit in a rocket, and that rocket, let's say, has achieved a speed of about 99% of the light. Getting it? What I'm trying to say?
Yes.
Suppose they are, let us just say that there are two kids. One of the kid you keep here on Earth, and one of the kid is made to sit on a rocket, and that rocket is traveling almost at a speed of light. Let us say it has achieved a speed of 99% of the speed of light it has achieved. Getting it? And that kid returns back to Earth. Okay, by the time when that kid would be returning back to Earth now, that kid would be only, let's say, 5 or 6 years older, but the other kid who was still on Earth, he would be much older. Let's say at that time, if that kid was, let us say, 7 or 8 years, by now he would have been of 80 or 90 years. Getting it? So all of these are some interesting concepts that is related to this thing which we we're discussing, that, right? So as of now, it is not possible for any matter, for any substance to travel faster than the speed of the light. Okay, now, so it's, since it's the fastest speed in the universe. Got it? Anyways, getting back to the basic things, right? So we discussed about reflection. Okay. And we have also learned about the laws of reflection in the classes, and the types of the reflection we have discussed that. Okay, regular and the irregular reflection we have learned. And we did learn about the image also, right? So when we look into the image, so we see our, when we look into the mirror, then we see the our image being formed in the mirror. Okay. And then we have also learned about the characteristics of the image that is formed by a plane mirror. It forms a virtual and upright image. Size of the image form is same as that of the object. Okay. Some of the things we have discussed, we're going to revisit that. Types of images, we have learned that there are two types of images formed. One is the real, another one is the virtual image. Real image, it can be obtained on a screen. Okay, it is usually inverted, it is upside down. Virtual image, it cannot be obtained in a screen. The rays actually do not actually meet when a virtual image forms. In the case of the real image, rays of light are actually meeting at a point. Okay, so these are some of the things we have discussed. We did also learn about the types of mirror. Types of the mirror we have discussed. Particularly take a look at this slide here. So we have discussed types of the curved mirrors. Curved mirrors are also known as, what's the another name for curved mirrors?
So concave and convex.
No, spherical mirrors also. Okay, no? We also them as the spherical mirror. Okay, no? We call them as a spherical mirror just simply because suppose if you were to have a sphere like this. A sphere, you understand? A spherical shape, right?
Yes, sir.
Okay. Like a ball is a basically having a spherical having a spherical shape. So if I were to cut it from the middle, so I will be having two curved mirrors, two curved objects. Okay. So one of them would be making up the, like this one would be the convex mirror. Now this one would be convex mirror. Getting it, guys? Convex mirror. And the other half would be the concave mirror, whose reflecting surface is bent inward. So they are taken out of a spherical object here. Like this is taking out from a spherical glass here. So that's why they are also called as a spherical mirror. Getting it? Why they are also called as a spherical mirror?
Yes, sir.
Also, when the rays of light falls on a concave mirror, it will come to meet at a point. So thereby it is also, in another word, it is also called as converging mirror. And in the case of convex mirror, when the rays of light falls on it, it diverges into different directions. Thereby that is also called as diverging mirror. And the image that is formed by the concave mirror, this one over here, we have learned that it can either be virtual and erect. And I told you it will be easier to remember the property of image formed by the concave mirror. Okay. Generally, you might be getting confused whether the image form will be real or virtual. So in this case, it is both real and virtual. It is both inverted and erect. It can be erected. It can be inverted image also. Okay. An object can be of the same size, bigger, and in fact smaller than that of the image. I mean to say, image can be of the same size as that of the object, larger than it, or even smaller than it. Then we discussed about the application of the concave mirror. Also, I have drawn a diagram, and I have got the picture of that actual solar furnace here, as you can see here. So that is having a concave shape now. Getting it? So then the dentist will also be using such kind of mirrors in order to look at the tooth decay, look at the dental problems. Getting it? So there it is used. It is used in the torches. It is used in the microscopes and telescopes also. Then we had the convex mirror, whose reflecting surface is basically bulging outward. Okay, so the property of image formed by this one is also easy, since it will be always forming a virtual image. It will be upright, basically erect, and will be forming images that will be smaller in size as that of the object. So hope this much should be clear. And these are the uses of convex mirror: used as a rear view mirror, used as security mirror in door peepholes, and also used in microscopes and in telescopes. So that was all about mirror. Okay. Particularly, we had also discussed about the plane mirror, and these were the properties of images that are formed by the plane mirror. Virtual, okay, it will be laterally inverted, image is erect, it is of the same size as that of the object, and the distance between the object and the plane mirror is same as that of the distance between the image and that of the plane mirror. Then we were discussing about the lenses. So we had learned about the lenses, right? So it would can be made out of a glass or plastic. Okay. Basically, if both the sides of that glass is curved like this, it is curved outward, so that will be a convex lens. Okay, you can remember from you will be able to recall the shape of the convex lens from this fact that convex mirrors reflecting surface is also bent outward, and its surface is also bent outward. Getting it, Abu Bakr and was?
Yes,
Okay.
sir.
So the rays of light that will pass through it now, notice it is converging at a point. It is meeting to converging at a point. But in the case of the convex mirror, what was happening? Were the rays of light converging at a point, or were they diverging?
Sir, diverging.
Diverging, no? So if you were to compare it with the convex mirror, no? So convex mirror is called as diverging mirror because when rays of light falls on it, it gets diverged into different directions. But what can you say about the convex lens? Will you call it as a converging lens or a diverging lens?
So converging lens.
Getting now? So we can also call this as the converging lens. Okay. As for the concave lens, now remember the concave mirror which we have discussed. See that these are the rays of light that were falling on it. After reflection, all of them were coming to meet at a point now. Getting it?
Yes, sir.
So what were we calling that?
Converging mirror.
Converging mirror. What will you say about the concave lens? Observe how the rays of light are passing through it.
Diverging lens.
Good. Priyanka is absent today, no? Yesterday also she was absent. So hence concave lens will be called as the diverging lens. Diverging lens, okay, no? So hope that should be clear. Now, the type of image that is formed by a convex lens, it will be real and inverted. Always note it down that real images that are formed, usually in almost all the cases, real image is always inverted. It will be upside down in almost all of the cases. Okay. Then image will be larger and will appear closer to the lens. Basically, the image formed by the convex lens will be larger. Which one we are talking? We are talking about this one here. Getting it? So that's why when you are looking at tiny letters or some tiny objects using the help of a magnifying glass, does it not look like the tiny objects are closer to the lens? Yeah.
Yes, sir.
Suppose you are looking at very tiny characters, tiny objects, and when you look it under a microscope, it appears as if those objects, those characters are very close to the lens. So that is one of the property of this convex lens here. For the case of concave lens, it will form a virtual and erect image and it will form a smaller image. It will form a small image and it will appear as if the images are images that will be formed, that will be viewed with the help of concave lens are farther away. Getting it? So these are the properties of the concave and the convex lens. Okay. All you have to do once you'll be getting the PPT, make sure to revise these properties. Okay. Also observe the convex lens here, right? So this is the image that is being formed by the convex lens. This is how you'll be looking at the objects. Getting it now? So a large image is being formed. Okay, a large image is being formed by the convex lens. Okay, and it will appear. And in the case of the concave lens, a small size image will be formed. Getting it, guys? So these were the things we have discussed. And today we are going to learn some interesting things. Okay. The last class we had, we did learned about the sunlight. Okay. So sunlight, usually the sun's rays that you see, you are only able to see the white light in the sun's rays basically. You don't seem, it does not look like it does have many colors, right? But you must have noticed the rainbow, right now? Regarding the rainbow, I did told one important thing. In which situation you will be able to observe the rainbow? When the sun will be behind you or when it will be in front of you?
Sir, behind.
Behind you. Okay. Also, sun will be at lower altitude in the sky. Okay. Anyways, so you must have noticed the rainbow, which usually appears after the rain when the sun is low in the sky and it is behind you, basically. Okay. So you must have seen this arc of seven color. Okay. In the yesterday's class, we had discussed how exactly it happens, right? So the rainbow formation is associated with the phenomena of dispersion of light, no? Right? Basically, white light splits into seven component colors, right now. So we had discussed about the concept of dispersion in the previous class, which basically states that it is the phenomenon of splitting of white light into its constituent colors when it will be passing through a prism or when it would be passing through a similar medium like these tiny water droplets that will also act as a tiny prism. Getting it, everyone?
Yes,
Yes,
sir.
sir.
So it is the phenomenon of splitting of white light into its constituent colors when it passes through a. Do you guys have a prism? A glass prism
No, sir.
or a similar medium or a similar medium? Okay. So basically, what was the reason behind this? What was it happen? What was the reason behind this? Basically, first we already know that white light is not one single light, but it is having seven constituent colors in it, seven constituent lights in it of different colors, right? So when the white light enters into a different medium, so thereby light of different color will be traveling at different speed through this medium, because of which all of them would be bending at various amount, at different amount. They'll be bending at different angle here. Getting it now? Since their speed is different. Getting it, everyone? What I'm trying to say? Yeah.
Yes, sir.
Okay. No? So the bending of the constituent of the white light, all of them are different. Their speed is also different. The speed of violet ray of light, indigo, blue, green, yellow, orange, red, all of them travel at different speeds when it goes into a different medium. So that was the primary reason because of which they got separated. Okay, that is one important thing. Okay. Now, in the case of the formation of the rainbow, what we have learned that when the sunlight passes through the raindrops, so those raindrops were acting as the tiny prisms, right now? And we had observed what exactly happens. So when the ray of the light will be entering when the ray of white light or the sunlight enters the raindrop, at first what happens? Reflection or refraction is happening right at this time.
Sir, refraction.
Refraction is happening now because medium has changed. Okay. Then again, here what is happening? All these rays of light have got
Sir, reflected.
reflected from the internal surface of the raindrop. Okay, as they will be exiting the raindrop, so again what is happening here? Since there is change of medium, so for the second time
Sir, refraction.
refraction happens. Okay, and are only white and red color here, or do you have all the seven colors? All the seven colors will be exiting out of this. Okay, now you not only get violet, but you have indigo, blue, green, yellow, orange, red, all of them. Okay, so that is the case. Okay, now see, this phenomena for the very first time, it was explained by Newton. Okay, no? Abu Bakr, just read the paragraph about the dispersion of this light here. Read this. I guess you can hear me.
Yes, sir.
Yeah.
Dispersion of light. In the year 1665, Newton discovered by his experiments with glass prisms that white light, like sunlight, consists of a mixture of light of seven colors.
Mm.
Newton found that if a beam of white light is passed through a glass prism, then the white light splits to form a band of several colors on a white screen. The band of seven colors formed on a white screen when a beam of white light is passed through a glass prism is known as a spectrum of white light. The seven colors of the spectrum are red, orange, yellow, green, blue, indigo, and violet.
Good. Okay. So Sir Isaac Newton in the year 1666, not 1665, okay now. So in the year 1666, he conducted the experiment. He took a glass prism, okay now, and he passed a beam of white light. How he would have passed a beam of white light? Basically, he might have taken a cardboard, in that he might have made a tiny hole, and on the other side he might be holding a torch. Getting it now? Okay, can you tell me, guys? You guys tell me that what do we call this property of light when it is traveling in a straight line?
Sir, rectilinear propagation of light.
Good. So basically, he made the white light to pass through a glass prism, and he observed that the light is split into a band of 7 colors on the wall. Like there was a wall over here. On that wall, he saw the band of 7 colors here. Getting it now? So Newton concluded that white light consists of several kind of colors, different kind of colors are there in it, and each color would be traveling through this prism at different speed. Okay, now it is traveling at a different speed. So his observation was as follows. First, he observed a band of 7 colors on the wall. Further, he gave an explanation to this, that why it exactly happened. So in the explanation, he basically said that he concluded that each color that is traveling through the prism, each one of them is traveling at a different speed. So each color travels at a different speed. Okay, that is first thing which he concluded. Okay. Further, he concluded that the violet light here, violet light or the red light, they are bending more as compared to other. You can observe here which one of them is bending maximum. Isn't it the violet and the indigo and the blue? These ones are bending more as compared to other. No, observe this here. Like it is going here like this. The white light is going like this. Okay, and the violet light or the indigo and the blue, they have bent maximum now. Like this is suppose white light, and that is the violet, and there you have the indigo, you have the blue like this, and the red light is almost like this, suppose like this. You guys getting it what I'm trying to say?
Yes, sir.
Abu Bakr, you also getting it, right? So
Yes,
violet
sir.
or indigo blue, like these lights were refracting more, they were bending more. Okay, na? Because they will be slowing down more when they enters the glass. Their speed decreases more. They travel at a much slower speed as compared to the other other ray of light here, other colors of light. Okay, now so just think about it. Like in the traffic signals, why do we use the red color as a stop sign? Hmm? Like in the railways or in the vehicles, we use this. Yeah, there is an interesting
Because it travels faster.
okay, that is one of the reason. Plus, it scatters very less. Okay, and it does not scatter that much, and it can travel. It can travel further distance. It can be seen from the furthest distance. It can be seen, because of which it is a very ideal for signaling danger, or if you have to stop some vehicle, so that can be used. That is one thing. Okay, also some other things you must have observed, like this is something which we have already discussed in the previous classes, right? When you will be taking two glass prism, one of them is placed inverted in respect to other. So when the band of 7 colors will be re-entering the prism right now, so they will be basically combining to re-emerge as a white light. Okay, you guys need explanation for this, or is it clear? Like we have discussed this one already. Yes, Gauss and Abu Bakr.
It is
Okay, there is this important thing which we are going to discuss. Just observe what is happening here. Hmm. This is called as Newton's disk. Okay, no, we call this as Newton's disk or Newtonian disk basically. So what is basically happening here? It's basically a experiment that demonstrates that how white light is a combination of 7 color. So this here is an experiment. You yourself can also make this to show that white light is a combination of 7 colors. 7 colors. Okay. So this is called as the Newton's disk. Or also we call this by another name. Also it is sometimes called as disappearing color disk. Because the colors are disappearing, so we sometimes also call this as disappearing color disk. Okay, getting it. So basically what is happening here? Hmm, it is basically a disk in which you are having colors in the segmented form. Okay, no, like in this one several the colors have been repeatedly taken, but you will be taking a disk. Okay, and in this you will only be taking the 7 colors. If you want to make it, going to take 7 colors only. Okay, no, so you can take the blue color. Okay, then you can take the this color. Like you just have to take 7 colors in order to make this. Okay, no, so when it will be spun at a high speed, you will observe that after it's being spun at a high speed, so the colors will start to disappear and you will only see the white color. So what does this conclude? Yes,
So that white light consists of 7 colors.
white light consists of 7 color. Getting it now? So like this, you'll be taking 7 colors in total. Like, okay, so Newton's disk can be used to show how the 7 colors can again be combined to form the white color. Just like with this example, also we can see that we can again obtain the white color once all of these light will be combined when it is made to pass through a glass prism that is simply put in an inverted position in respect to this glass prism, right? So here we will going to simply first divide the area of the Newton's disk into 7 equal parts. Okay, and each part is colored. Okay, now like it has to be colored using the using 7 colors here only. Getting it? So when it is rotated at a high speed, so it will appear white in color. So this is just one experiment which we can do. Then you might be having this question that why sky appears blue. Ever thought about these kind of questions, like why it appears blue and why only blue? Why does not appear violet? Yeah, getting it? So let us discuss this. Basically, what happens when the sunlight reaches the Earth's atmosphere? So the sunlight is scattered by the molecules in the air. Getting it? Now they are scattered by it, and this amount of scattered, like the how much a particular color of light gets scattered is different. Okay, na? It gets different. Particularly, the blue and the violet lights gets scattered the most. They get scattered most. So as you can observe here, this is the white lights that is entering into the Earth's surface. Okay, so you can look at all the component colors of the white light. The red one is getting least scattered, isn't it? Then observe the blue light here. So the blue light or the violet light gets scattered more. In fact, blue light gets scattered more than that of the violet light. Getting what I'm trying to say, guys? Hmm? So there are so many air molecules into the atmosphere. Like there are so many tiny air molecules into the atmosphere, and these air molecules will make the different rays of light scatter. And the one that scatters the most is the blue light. Hence, the sky appears to be blue. Okay, and this sky does not appear purple because there is not as much as violet light in the sunlight as there is blue. Okay, plus our eyes are more sensitive to blue. Getting it? Our eyes are actually more sensitive to the blue color. That is one of the reason. Plus, scattering of blue light occurs more than that of the violet light. Why we discussing it in context of violet because here first you are getting the violet light here, violet and indigo. Is this thing clear to everyone regarding like why the sky appears blue?
Yes, sir.
Okay, so let me just write few important points in regard to this. Okay. So when sunlight reaches the earth's atmosphere, when it reaches the earth's atmosphere, it gets scattered by the air molecules, okay. Further, blue light gets scattered the most, while red light is scattered least. Then further, our eye is also much sensitive towards the blue light, and hence the sky appears to be blue. Is the sky actually blue? Hmm? Is the sky actually having a blue color?
No,
Yes?
sir.
No, it only appears to be. Getting it now? Okay. Also tell me, when the astronomers look at the Earth from space, how does the Earth appear? When the astronomers would be viewing the Earth from the space, so how does the Earth look like?
Sir, blue.
Blue, right? So what could be the reason behind this? Like the majority of the Earth looks blue, like almost 70-71% of the Earth looks blue, right? Some of the part looks white also because of the cloud also, right? Some of the part looks brown and yellow and green as well. Okay, so why is it so that uh, why is it that when astronomers view the Earth from space, then majority of the Earth looks blue? What could be the reason behind this? Try to think about this. Hmm? Yes, Abubakar and Gauss. See, interesting phenomena in regard to this is that the majority of the oceans, Earth is having like the majority of the surface of Earth is basically covered with the oceans, right? So the ocean water would be absorbing all the colors of light except for the blue. So blue light is being reflected. Getting it what I'm trying to say. That is why the Earth would be mostly looking blue and hence also called as the blue planet. Let me just draw some important diagram for this. Say that these are the water bodies on Earth. Just suppose. Okay, no. Say that these are the water bodies. So what happens when the when the sunlight falls on it, no? So almost all the color of light gets absorbed into the water bodies. But which one is getting reflected? The blue ones. The blue ones, okay, now? And hence the Earth appears as blue to the astronomers who would be viewing it. Okay. Also, you must be aware of this concept, or if not, just know that, like, for example, if you're wearing the white, let us say that if you are wearing a black colored cloth, so why does it appear as black only? What exactly happens here? Hmm? Suppose that if you are wearing the black colored clothes, okay, or let us just suppose, for example, if are wearing a red colored cloth, let us say, so why does it appear to be red only? What is the exact reason? The thing is that all the rays of light that is falling onto that cloth is getting reflected, is being absorbed except for the red color. Yeah. So a particular object basically a particular object looks like have a certain color because it will be reflecting that color. Because of that only it has got that color. Getting what I'm trying to say?
Yes, sir.
Like when the rays of light would be hitting an object, some of it is absorbed, some of it is reflected. Okay, so suppose if you are wearing a red colored t-shirt, let us just suppose. So what happens when light is falling on it? So most of the light is getting absorbed into it, but the one that is being getting reflected from this is the red color, is the red ray of light. It gets reflected. Is the concept clear now? Yes. So the color of an object is determined by the type of light that it will be reflecting. If it reflects the red light, it is having the red color. If it reflects the green light, it is having the green color. Okay. All right. Now we have got some questions to do. If you guys have any questions related from the chapter, please let me know. Yes. I suppose no. Answer the given questions.
Sir, opaque mirror.
Opaque mirror. Good.
Sir, refraction.
Okay, what about you, Abubakar? See, everyone's participation is important into the question and answer session, especially. Answer the third question also. Can you draw the diagram for third question, Gauss? Draw the diagram also while solving the third question. Okay. By the way, your answer for second question, that is correct. Okay, so that is simply refraction.
Sir, is it uh, angle of reflection is 30 degrees?
Hmm. That is correct. Have you drawn the diagram?
Sir, I'll draw.
Okay, draw it. Yes, Abu Bakr, you there in the class now?
Yes, sir. I'm
Yeah, you haven't been responding.
Sir, I drew it.
Hmm. Have you done it? Can you show it in the camera?
Yes, sir. Sir, 1 minute, sir.
Okay, okay.
So can you see it?
Just 1 minute. Let me zoom it out. Just 1 minute. Bring it a little up. Move it up. Okay, that is correct, but yeah, that is correct. But you can just draw the simpler diagram. Okay, no? See, whenever you'll be asked to draw a diagram for the reflection taking place from a plane mirror, so just draw this vertical line like this. Okay, then draw these, shade the back of this. Okay, now this shading means that this is the reflecting surface basically. Okay, then you just draw one incident ray. Make sure to write the arrow, draw the arrow. Then you draw the reflected ray. Next, you have to draw the normal. I suppose you haven't drawn the normal in the diagram. Yes, was.
Yes,
So
yes, I had not drawn it.
make sure you draw it. Also label the different rays like this is the incident ray. That's the Abu Bakr. You also have to do this. That's the reflected ray, and this here is the normal. Okay. Now, the angle of incidence. The question was what happens when light strikes at a plane mirror at an angle of 30 degree to the normal, right? So 30-degree angle is formed between these two rays now, between the incident ray and the normal, right? So that is the 30 degree. So question is asking what would be the, yeah, these are the options given here, right? So the angle of reflection is also going to be 30 degree. By the first law
Yes,
of reflection, we know I is equal to R. This is angle I, this is angle R, basically angle of reflection. So that is also going to be 30 degree. Okay. If suppose if I were to ask this question, like what would be the angle formed between the incident ray and the plane mirror? Can you answer that? Yes, Abu Bakr and was. I'm asking about this angle here. Like what would be this one? That is also very easy to answer. Hmm?
so 60 degree.
Very good, right? Because this complete angle is 90, so there, but this will be 90 minus 30 and hence 60. Okay. Next, you guys mention the given, mention the lenses. The lens A, what is the lens A and what is lens B? Okay, I have not drawn the correct shape of the lens as of now. Keep that in mind, okay? Otherwise, you would be getting the answer. Yeah. Both of you will be answering this one separately in the chat box. I want both of you to participate in this. You guys know where you have to answer. No, drop your answers over here.
The question number 3.
No, this question, like count this as question number 4. As of now, I have asked this question. You have to mention the name the lenses. Name it as A and B. Was name it as A and B. Rather than just writing the name of the lens, first write A equals to this lens, B equals to this lens. Give your answer in that manner. Okay. So these are the other names by which we know that now. But what's the actual name of the lens? Write down that also. Abu Bakr, you also. Just observe what is happening to the rays of light that passes through it. Both of you turn your cameras on in the class first. As the rays of light are passing through it, it is converging at a point. Yes, we will call the first one as converging lens. But is it a concave or a convex lens? Hmm? You will notice I have not drawn the correct shape of the lens. Otherwise, we'll be getting the answer then. What about you, Abu Bakr? Yes. The first one is the convex lens. Okay, not the concave gauze. I suppose the in prop like you have answered the first one as the concave, I suppose. Hmm. See, the first one is the convex lens. That is also called as converging lens. The second one is the concave lens. Okay. So the correct shape, if I were to now correct the shape, so it would be looking like this. Thicker in the middle and thinner at the edges. And this one here is the concave lens. Okay. So on lenses and mirrors, you guys need to revisit these topics. Okay. Answer these questions also.
Sir, when light travels through air.
Good. Next.
Sir, scattering of shorter wavelengths of light.
Good. Okay. So you have violet, indigo, blue, green, yellow, orange, and red. Right. Red light has the longest wavelength, because of which it is visible from very far off places. It is visible at further distance, while violet or indigo blue light, these are having short wavelength. Okay, short wavelength, because of which they are not visible from a very far off distance, and they will be scattering more. The scattering of these rays of light takes place more, while when you go higher up to the orange or red, they scatter the least. So first question, explain how the reflection of light occurs when it strikes a plane mirror. And you have to describe the law of reflection also. Abu Bakr, I'm going to appoint the question one to you. I'm going to appoint the questions now. Next one you are going to explain. Okay. Just explain what is a refraction. No need to illustrate an example, just because this portion is not there in detail. So just explain refraction.
Sir, when light passes through a transparent object and change of medium takes place is called refraction.
Okay, see, basically the refraction of light is basically when the rays of light moves from one medium to another, then it bends. So that bending of light when it goes from one medium to another is called as a refraction of light. Okay. So define this once again. Define the refraction once again.
Sir, the bending of light
Passes
when it passes through
passes from one medium to
passes from one medium to another medium.
good. Yes, Abu Bakr.
The reflection of light is light when it hi- it hits a smooth surface.
Continue. Yes, you were explaining well. Continue, Abu Bakr. Particularly, you have to explain this in relation to the plane mirror. Yeah. So what we have discussed at when the
Uh,
just take Mhm.
when the light ray gets hit on the
plane mirror,
it get it gets reflected back.
it gets reflected back. Okay. And it follows the law of reflection
Uh,
where angle of incidence is equal to angle of
Angle of reflection is equal to the angle of incidence.
good. Okay. Third one, how does the scattering of light explain why the sky appears blue during the day? Yes. Okay. Why during the night sky does not appear to be blue? What is the simple reason for that? Yes. Gauss. Why the sun does not appear to be blue during the night? Very simple reason. Yes. The obvious reason is hmm, there is no sunlight during the night. So how will the scattering of the blue light take place? Hence the sky doesn't appear to be blue. Okay.
Yes, sir.
Explain this question. Anyone who would like to explain question number 3? How does the scattering of light explain why the sky appears blue during the day? For reference, you can look at this animation here. Take your time, no worries. So first tell me, out of all the 7 colors of light, which one scatters the most?
Sir, blue light.
Blue light. So they are scattered by what? What scatters them? When the
Sir,
white
the molecules.
air molecules, no? Okay, so how you should be explaining it? That when the sun's light enters into the atmosphere, so the blue light or the violet light, particularly blue light, gets scattered by the gas molecules, by the air molecules. And hence during the day, sky appears to be blue. As simple as that. Plus, our eyes are sensitive towards the blue light, no? Yeah. Abu Bakr, read the following paragraph which I have written here. In fact, all of them gets scattered, but the blue light gets scattered most. Okay, and the least scattered light will be
Sir, red.
red. Good. Yes, Abu Bakr, you there? Okay,
Yes.
guys. Yeah, Abu Bakr, read the given paragraph, no?
When sunlight reaches the Earth atmosphere, it gets scattered by the air molecules. Blue light gets scattered the most, while red light is scattered least. Wha- Our
Our.
our eye is also much sensitive towards the blue light, and hence the sky appears to be blue.
Good. Okay, and regarding like why the sky, Earth is called as a blue planet, hope that should be also clear. Like the water bodies would be reflecting the, yes, they reflect which color of light most? Isn't it blue,
Yes,
right?
sir.
Okay, that's why it appears to be blue. Okay, going to question number 4. So this one is simple, right? You can do this obviously. Okay, tell me an example of a opaque object. Okay, and that you can make a translucent. Do we have one such example of a opaque object that can be made into a translucent object? Yes. Paper usually is a, what is a paper? It's a
Sir,
opaque object. Continue. How can you make it translucent? By simply applying some oil on it, no? So it will become translucent. Okay. Question number 5 particularly. So describe the role of convex lens in focusing light and how is it used in optical devices like magnifying glasses and in cameras. So first describe its role in focusing the ray of light, focusing the light. Yes.
sir, when light rays pass through the convex lens, they get uh, they get converged into one.
Converged at one point.
Yeah, they get converged at one point.
Hmm.
A bigger image is formed, and it is used in magnifying glasses because when we see through it, um,
Hmm.
uh,
Objects or the
the
characters appears to be closer than they actually are.
yes.